Okay, welcome back everybody. Happy Tuesday. Today, April 18, we're going to do all of lesson 22 and start lesson 23. They're highlighted down here. Graphing parabolas is the first part, and then the quadratic formula is the second part. Coming up, April 27 is our fourth quest, so I guess that's 9 days from now. Thursday next week, that'll be our fourth quest. Any questions on the calendar? Okay, so let's jump in on the bottom of page 179. You can see I've written this equation here. This is just going to refresh our memory on some stuff that we did last class, and also we're going to end up using this equation in the new stuff at the start of today's class. So let's solve this equation. First observation, the highest power in this equation, highest power on the x is what? It's 2, right? And this is an x squared equation, and oftentimes the technique with x squared equations is to make one side equal to what magic number? 0. The goal is a 0. So let's subtract the 3 from both sides to get a 0 on the right-hand side. And I'm just going to squeeze in here right up at the top. We're going to be playing around a bunch with things in the form ax squared plus bx plus c. And so it's going to be important for us to recognize, oh, a is always the number touching x squared, and b is always the number touching x, and c is always the number with no x. So in this particular case, how much is a? The number touching x squared is -1. The 1 is invisible. The negative sign is there. So a is -1. How much is b? Is 4. And how much is c? -3. And we got to say that negative sign there. So we'll use that today. Okay, so the goal here is to factor. If we could figure out what goes inside of those parentheses, then we would say, hey, I know I've got some number in one hand multiplied by some number in the other hand, and I got 0. What has to be true about one of these numbers? One of these numbers has to be 0. The only way to multiply two numbers and get 0 is if one of them was 0. So if we can figure out what goes in the parentheses, then the problem is going to be easy. So figuring out what goes in the parentheses is our big old factoring problem. We'll go through our routine. It's always the same 3 kinds of factorings, always in the same order. Greatest common factor first. Can you pull anything out of all 3 of these terms here? Nope. Next is the difference of 2 squares. Is this a difference of 2 squares? No, it doesn't have that very particular difference of 2 squares format. The last method was the box. That's going to be the winner here. So let's go ahead and refresh our memory on the 2x2 box here. And I'll go ahead and put in sum equals, sum equals, and product equals. All right, and so we're just going to start filling in the box, and those two sum and product lines in the right order. Where does that negative x squared go? Top left, negative x squared right up there. Where does the plus 4x go? That's the sum. It is always the sum. I'm going to put a plus sign in there to remind myself it's positive what we're looking for. Where does the -3 go? Bottom right, right there. And once we've got those things filled in, we get the product by just multiplying those two guys together. What do you get when you multiply those two? 3x squared. I'm even going to put the plus sign there too, just to highlight it is a positive 3x squared. Okay, so we've got a bunch of the stuff filled in. Now we're at the hardest part. This is the detective part. We're looking for 2 things to put in those blank boxes that have a sum of positive 4x and a product of positive 3x squared. This is the hardest part. This 3 here is pretty small, which makes this fairly straightforward, but if that was 120x squared, there'd be a lot of factors to try. But let's just list the factors. 2 things that multiply to positive 3x are 1x and 3x. Is there anything else that multiplies to positive 3x squared? 3x and 1x, but it's equivalent to what I've got there. So, but we could also make them both negative, couldn't we? And sometimes you need to. -1x, -3x. That will also give you a positive 3x squared when you multiply. So we've listed them all. And then we're just looking for the one that has the right sum. Does one of these have a sum of positive 4x? Yeah, this one right here, 1x plus 3x is indeed positive 4x, which means we put those guys in the box in any order, but why don't you just copy my order so we're all looking at the same thing. Positive 1x, positive 3x. Again, it makes no difference where you put those two, but just put them there. Okay, and now we're ready to grab stuff and start putting it outside. I always start in the first row and I look for the greatest common factor. What goes into negative x squared and also into x? What's in both? X. Anything else? I don't see anything else. If you wish, you could pull negative x out. Totally fine. You'd get a different answer. Like all of the things we're putting on the outside would change. So sometimes there's more than one option here. But anyway, I think that's good to start. Then we're going to come up here and we're going to say what two things. Yeah, it's got to be a negative x. Everybody see that? Right, we multiply and the area is supposed to go in the box. Let's go up here. So whatever we put times this 1x is supposed to be that positive 1x. That's got to be plus 1 right there. And then over here, yeah, so this is the tricky part. So some people mistakenly think, oh, in the first row, we pulled out the greatest common factor. And so we should just pull out the greatest common factor everywhere. And it just doesn't always work. What is the greatest common factor of these two things? It's 3, isn't it? You would pull a 3 out. 3 is not the right thing, because if you multiply that negative x times this 3, does it give you the 3x in the box? It doesn't. So the only time we do the greatest common factor is that first row. It's just do it once. It actually makes no difference what row or column, but you only get to do that once. So what do we need to put out here to make the positive 3x? It needs to be a negative 3. Okay, and then we're just going to grab the stuff from the outsides of the box and throw it here in the parentheses. I'll start on the far left. I see x minus 3, that goes here. And then going right across the top, negative x plus 1. Okay, and now we're going to finish, and finishing is pretty easy. Remember, you had a number times a number equaling 0, so one of these numbers had to equal 0, and we just write those two much simpler equations. Either x minus 3 is 0, or negative x plus 1 is 0. Okay, common error. I've seen this so many times. With enough practice, so how much is x from that first equation? X is 3, right? And just add 3 to both sides. That's correct. So with some practice, some students start to get a little bit lazy, and they say, oh, whatever is sitting right here, I just have to change the sign, right? It was a negative 3. The answer is positive 3. So then over here, if you just change the sign, what do you get for x? Negative 1, right? By just changing the sign. Is that the answer? It isn't. The way I would solve this would be to add x to both sides, and I would get x equals what? 1, which is not what you get when you just change that sign. So don't take a shortcut here. Just solve the equation. It's not hard to solve the equation. So you got your two answers, x equals 1 and x equals 3. Another reason I don't like that shortcut, if in the parentheses it had been like, 2x plus 7, and then you make that equal 0, is the answer negative 7? No, right? You have to solve that equation. Subtract 7, then divide by 2. Forget the shortcut. It's not worth remembering. Okay, so those are our two solutions to the original equation up there. X equals 1 and x equals 3. Questions on that? Okay, so let's jump here at the top of 179. This was a review from last time, but we're actually going to use those numbers later today. Okay, so our daily summary. In this lesson, we learned how to graph quadratic equations. 0, recall the intercept method for graphing a line. Fill in the table in order to graph the line 2x minus 3y equals 12. So this is like a review problem from way back. The intercept method said, hey, if you want the y-intercept, you let x equal 0. So I've already pre-filled in here the 0 for the x. And so if you plug in 0, in that equation for the x, we go 2 times 0 minus 3 times y equals 12, right? And that's pretty easy to solve for y. So 2 times nothing is nothing, so we just get negative 3y equals 12. And how much is y? Negative 4. So that negative 4 goes right there. So that's the y-intercept. And if I want to find the x-intercept, that's letting the y equal 0. So we just go back to the original equation, replace y with 0, copy everything else, and solve that for x. Whatever number we get for x is the x-intercept. What do we get for x? 6, right? 2x equals 12, so x is 6. That goes right there. Another common mistake, I know I talked about this when we were graphing lines way back when, but people will say, oh, x is 6, y is negative 4, and they'll do this. Don't write this. X is 6, y is negative 4, and they'll plot that point, 6, negative 4. Is that an x-intercept? No. Is that a y-intercept? No, that's like a hybrid of the two intercepts, right? Really, it should be 6 comma what? 0. And really, it should, 6, 0 is good. And then really, it should be what, negative 4? 0, negative 4. They're not, the 6 and the negative 4 are not part of the same point. So 0, negative 4 is down here, and then 6, 0 is up here. And those are our 2 points that we can connect with a straight line. You can see that this 6, negative 4 is just like a combination of the two, but it's not on the line. So with a straight edge, if you have one, connect the dots. Okay. So that was our way of graphing, one way of graphing lines, just the two intercepts. And so I'll say again, to find the y-intercept, you let x equal 0, and to find the x-intercept, you let y equal 0. And that was true with lines, and in fact, it's true with anything. And so today we're going to be graphing more complicated things called parabolas. They'll be curvy, but the way to find x and y-intercepts is exactly this same technique, right? Let one letter equal 0, and then solve for the other letter. All right, so let me get rid of this thing here. Okay, so here are three parabolas, three curves. The equations for these things are up here, like y equals 4x squared minus 4 is one of these. There's like a whole big old explanation here. I'd actually just like to jump to the part where we graph a parabola together. That's the hardest part, and that's what I'm going to ask you to do. So I'm going to skip all of this exposition on this page. You're welcome to read through it later on if you want to. But anyway, the goal is to graph one of these things. That's what we're going to do together on the next page. So number 4 says, here's how we sketch y equals negative x squared plus 4x minus 3. Y equals negative x squared plus 4x minus 3. We'll use the 6-step process detailed on the next page. So you can stay right here on this page. I'm going to jump temporarily to the next page. It says sketching the parabola y equals ax squared plus bx plus c. Same a, b, and c we wrote earlier today. It says step A, figure out if the parabola opens upward or downward. So you can have a parabola going that way or a parabola going that way. If the a value is positive, the parabola opens up. And if the a value is negative, the parabola opens down. So taking a look here, how much is the a value if it's supposed to be ax squared plus bx plus c? A is negative 1, right? And so again, if the a is positive, then this curve opens up, and if the a is negative, the curve opens down. So in this case, since a is negative 1, which is less than 0, this parabola opens down. So ultimately, we're going to see, don't draw this yet because we're not there, but we're going to see something like that as opposed to something like that. Okay, and it's actually pretty easy to remember which one it is because the red one, yeah, right, red one kind of looks like a smiley face. Positive people are generally smiley, so positive A, smiley parabola. Negative people, unhappy, frowny, negative A, We got it. Okay, so stay right here. I'm going to go here. B, find the location of the y-intercept. How do you find a y-intercept? You always let what equal what? Let x equal 0. It was true for lines. It's true here. So that's what we're going to do next. Let x equal 0. So let's let x equal 0 right here. If we let x equal 0, we go y equals negative 0 squared plus 4 times 0 minus 3, right? Go ahead and write that. So we'll just change all the x's to zeros, and then we do arithmetic. What do we get? Negative 3. And so that means that we now have the y-intercept. It is a point. It has 2 numbers associated with it. Okay, definitely the y is negative 3. We just found that. How much is the x? 0. It's the first thing we did. Let x equal 0. So we've got 0, negative 3, and we're going to plot that point right now. 0, negative 3. The parabola for sure hits that point. Okay, and if you're looking for patterns, you might recognize there is a shortcut for finding the y-intercept when the equation is in this form. Do you see that negative 3 sitting in the original equation? Yeah, it's that number that's over there by itself. Don't memorize it. It takes like 3 seconds to plug in x equals 0, and you got enough stuff to memorize already. So just plug in x equals 0. Okay, you stay here. I'm going to the next page. C, find the location of the x-intercepts. How do you find x-intercepts? In general, you let y equals 0. Same thing we did earlier with the line. So we're going to let y equal 0. So let's do that here. X-intercepts, let y equal 0. So that means a 0 equals, and you copy the entire rest of the equation with all those x's. Okay, and that equation, if you go back a page, will look familiar. Isn't this the equation we solved first thing today? I think the 0 was on the right-hand side, but it's the same equation, right? This is the equation we solved. At the end of the day, how much was x? We got 2 numbers. 1 and x equals 3, right? And there's a lot of steps in between the equation and the x equals 1 and x equals 3. It's all the stuff we did at the start of today's class. So I don't mean to like hide it. You still have to do like the whole box part of it is written out for you. You got to do the whole box method to get those 2 numbers, x equals 1 and x equals 3. Which means you now have 2 x-intercepts. It's not 1, 3. It's x equals 1, so for sure there's a 1 there. And how much is the y? It is 0, because the very first thing we did was change the y to a 0. And the other x-intercept was x equals 3, and how much is y? Also 0. 2 x-intercepts, 1, 0, 3, 0. Not 1, 3, not 3, 1. Go ahead and plot those 2 points, 1, 0, and 3, 0. Okay, don't write this, but if you are trying to imagine this new shape, this curvy, either, you know, like happy face or sad face, and you're trying to make it hit these points, you might get stuck. You might be picturing something like that, but then there's no way to get it to hit the other guy, right? Or maybe something like this, but you can't make it hit that green one down there. What's the problem with these ones? Is that the first thing we saw was that this is a downward parabola. Ah, okay, I can fit a downward parabola to those points. Yeah, that's the only kind that will work. So it kind of like these 3 points sort of confirm, yes, it's going to be a downward parabola. Okay, you stay here. I'm going to the next page, part D. It says find the x-coordinate of the vertex. So this is a word that we didn't define. It was on that whole page that we skipped. Yeah, so the vertex. So if you have a happy parabola, it has a special point that is lower than every other point, right? That is called the vertex of the parabola. If you have a sad parabola, you have a special point that is higher than all of the other points. That is still called the vertex of the parabola. So the one special point is called the vertex of the parabola. It is either the highest point or the lowest point, depending on what kind of a parabola you have. So if you look at the 3 points that we have, and we've already established that this is going to be some kind of a downward parabola like that, right? Okay, now I for sure don't know how high it is up here. I just drew like a rough estimate. But can you tell me what the x coordinate is at this point? What's the x right at this point? Has to be 2. It's got to be 2. Because we know that this special point, it might have been way up here. Like maybe it was like really thin and tall. But that special point has to be halfway in between, right? Like it's perfectly in the middle of the 1 and the 3. And so yeah, 2 is right there in the middle. So if I ignore, I'm going to erase this green point for just a second. If I ignore and I draw a parabola that hits those 2, I'm going to draw something really thin here, something like that. The vertex, the highest point is up there at 2. I could draw one that's not quite as thin, something like that. Highest point again is at x equals 2, right? I could draw something that is happy parabola, which isn't this one. But where is the x coordinate of the vertex? It is at 2. Are you buying that it's got to be halfway between those 2 x-intercepts, regardless of anything else? So let me get that one there. So we calculate the x coordinate of the vertex. So that little subscript of v is my way of saying we are representing the vertex here. So what is the average of 1 and 3? It is 2. All right, it's obvious, like 2 is smack dab in the middle. But in case it isn't obvious, how do you average 2 numbers in general? You add them and divide by, in this case, how many? 2, because we had 2 numbers that we added together. So that's the technique, right? Add the numbers and divide by 2. That's how we average them. And of course, we get the number 2, which is the number halfway in between 1 and 3. But sometimes it's not as obvious. Like if I said, like I want you to average that number and that number. What number is halfway between those? I don't know. I got to do a calculation, right? But for sure, I can add the 2 of them up and divide by 2, and that's going to be the answer. Okay, so I know that the x coordinate of that special point, the highest point, is 2. What I don't know about that vertex, the special point, is the y coordinate. But we can find it because up here circled in green is the map for this equation. If you tell me an x, I can tell you a y, right? What x do we want to know more about? 2. So you just plug in x equals 2 and use this equation to find the corresponding y. Let's do that. So we're going to write here y sub b. This is the y coordinate of the vertex. So negative, it was supposed to be x squared plus, what was it, 4x? 4x. I'm just going to leave blank parentheses here and then a minus 3 at the end. So this is my shell. Every x has become blank parentheses. And now what number is going into those parentheses? 2. It's just that. Okay, I've seen people get tripped up here. Is this 4 or negative 4? This is negative 4. That square is only touching the 2. That negative is waiting for you to complete the squaring process. Plus over here is an 8, minus a 3, 1. Okay. So then putting our 2 pieces of info together, we now have both coordinates of the vertex. What, comma, what? X for 2, comma 1, right? X first, 2, comma 1. Go ahead and plot that point at 2, comma 1. It should be perfectly reasonable. It should look like it's in the right spot. Two, comma 1. Okay, you are probably feeling pretty confident, comfortable that you could just connect the dots with something smooth and curvy, and it's fine. But I'm going to ask you to plot one more point. This picture doesn't look great to me because I know the parabola is like a really symmetric thing, right? Everything on the left is copied on the right. But I have a point over here with no partner plotted, right? But there's definitely a symmetric point for that y-intercept. So I'm just going to ask us to find it. Yeah, it's not, there's no formula I'm going to ask you to use. I just want you to like look at the picture and think about it. I know that between here and, so if I draw this line right through the middle, how far is it from here to here? 2. So then to the symmetric point, it better just be another 2. And then what point do you land on? 4, -3. So there's no, like, don't memorize, just look at the picture, use your brain, and figure out the symmetric point. Okay, and now you've got all the points. You got enough points anyway, so go ahead and connect the dots. Just want to try to hit all 5 of those if you can. And I will tell you, I've got like wide latitude. Some people are like really judgmental about their inability to draw parabolas. Like, I will not be as harsh a judge as you are of yourself, but I will judge harshly 2 things. So I'm going to tell you specifically the 2 things I want you to avoid. Thing number 1 to avoid. That is not a parabola. Parabolas are curvy, not straight. Okay, so do not draw something with a point up at that vertex. Thing number 2 that I want you to avoid is this. I drew something really curvy. What's the problem? And keep going, right? Like, this would be like really arrogant of me to think that this parabola exists only on the points that I drew, right? This parabola could care less about what points I picked. So just don't do that. Make sure you continue your parabola to the edges of the graph paper. That's all. Okay, any questions on drawing parabolas? All right, so on this page, you're going to use this as a guide when you work through the problems in the activity, but the 6 steps are all right here. You just got to go through them one at a time, and then at the very end, we connect the dots, okay? All right, raise a flag if I can help. I will walk around.